Welcome everybody again to another episode of the ideaXme show, the show that profiles the humans behind the really big ideas that are shaping the world and inspiring future creators, and for all those that like really great stories. I'm Ira Pastor. I'm here as your aging and longevity ambassador. And for the last several shows, we've been talking about different components of the aging process and the disease process, speaking to a wide range of experts in the fields of therapeutic and preventative interventions for the diseases and processes of aging. And one theme that we've been sort of brushing up against over and over again has to do with what we refer to as biomimicry, broadly defined as sort of the imitation of models, systems, and different elements of nature for the purposes of solving complex human problems. Living organisms have evolved all sorts of amazing, well-adapted structures and materials through natural selection, and hence give us a lot of good clues for how we develop new technologies moving forward that can be inspired by these biologic solutions. We've talked about some of these on previous shows, such as the regeneration potential of salamanders, the ability to slow aging in organisms like tortoises and so forth. Today we're going to touch on this theme a little further, and we're going to go into the area of the concept of biologically inspired medical exoskeletons. An exoskeleton, broadly defined, is an external skeleton that typically supports or protects an animal's body, in contrast to an endoskeleton, which is what we as humans possess currently. Examples of animals that have exoskeletons are insects like grasshoppers and cockroaches, crustaceans like crabs and lobsters, and so forth. They typically contain rigid and resistant components that fulfill a wide range of functional roles in animals, such as protection, excretion, sensing, support, and so forth. Human exoskeletons, based on this knowledge, are typically wearable devices that work in tandem with the user and can be placed on the user's body and act as either amplifiers or reinforcement to restore human performance. Exoskeletons can be made out of a variety of different materials: metal, carbon fiber, soft and elastic parts, and they can be powered and equipped with different sensors, actuators, or they can be passive. And current applications include, but are by no means limited to, improving the quality of life of people who've lost use of certain limbs, like their legs, help enable system-assisted walking, restoration of motor controls following illnesses, and so forth. Today's guest, who I'm quite excited to have with us, who is really right at the epicenter of this exciting field of medical exoskeleton development, is Ekaterina Bereziy. She is founder and chief executive of the company known as ExoAtlet in Russia. With degrees in both mechanics and mathematics and an MBA, she is leading ExoAtlet in the development and commercialization of adjustable, portable, battery-powered bionic exoskeletons designed to assist patients during the rehabilitation after diseases such as stroke, injuries, or unsuccessful operations. She was recently named one of the Young Global Leaders class of 2017 compiled by the World Economic Forum, and also sat with me on the World Economic Forum Human Enhancement Council. Ekaterina, thank you so much for coming on the show today. The first question we basically have, we want to give you the floor just to talk about you, your background, how you got interested in mathematics, mechanics, and then ultimately your journey to be the CEO of this company, which is at the epicenter of a really exciting area of bioengineering.
So it was not a coincidence, because I was born in the family, scientific family. So my parents, they were the robotic guys. So even their intellectual, so it's like the scientific intelligence and so on. So they developed robotics in the Moscow State University, and from my birth, I took part in some interesting. They discussed the interesting ideas with me and so on. So I was inside these fields from the beginning. And as the result, I had to pass the exams to become a student of mechanical and math faculty. I didn't have any other choices. So it was fatal for me, because when I finished this faculty, I tried to escape, really, and I became head of the industrial departments in one of the famous design studio in Russia. So it's a little bit of studio, and we developed the product it was the product design department. So we developed different kind of products. It was the electronic devices, and they're just devices that we use in our ordinary lives. So when I spent 5 years in the product marketing, so I communicated a lot with the manufacturers and with the engineers and with the designers, and we developed, for example, the microwave for Samsung, or it was really interesting products. And then, it's like the idea from the beginning of the life that you get from your parents, that you have to do something really interesting, so something really innovative. So every one of us has a chance to escape from their ordinary normal life to some crazy project. And it was the chance that we worked together with Michael, it's my partner. We worked together during one of the projects that we developed in product design. So he was on the client field, and I was in design team. So we developed together their TV set. So it was a very interesting project, and we knew each other for some years. So we decided to develop the completely new ideas, like the exoskeleton. And as I had the background from the Moscow State University, and a lot of friends of mine left, so they did not escape from that field. They were really, really engineers, not like me. They enjoyed a lot the development of the robotics, so they were interested in developing the exoskeleton also. So it was an idea that we decided to penetrate rather deep.
Mm-hmm.
And we decided that we develop the skeleton for 1 year. If in 1 year we get any kind of result that we can show to clients, to potential clients, to the investors, or to different people, so we will continue. It was on 2013. And in 2014, we performed the first prototype in Skolkovo village, startup village. It's one of the biggest events in Russia for startups. So, and we got the first prize. So it was really interesting for us because it was like the first really good results for the team. And we start to do it rather serious from that period. So we fundraised the money from the venture capital group, and we start to develop it like the big company, like the big robotic company. So that's why we think that the beginning of the project was not in 2013, but in 2014, when we presented first it for the big audience.
Mm-hmm.
So it's something like that.
Wonderful. It's interesting because you mentioned the ExoAtlet is a resident startup from the Skolkovo Innovation Center, and a lot of I guess I sit here in the U.S. And many are probably not that familiar. I'm somewhat familiar with it. So you have this historically, Russia full with wonderful science and technology over the decades. Maybe not so much ease of entrepreneurship and building small companies and so forth. And now, you have Skolkovo, you have basically what is an innovation city that has been set up. Set up Dmitry Medvedev, sort of formed it, and then it's headed by both Russian and American sort of chairs. I think Craig Barrett from former Intel CEO was involved, and Victor Vekselberg. Could you talk just a little bit, before we get into some of the things that you're doing on the exoskeleton side, can you talk just briefly sort of what it's like being an entrepreneur in Russia in 2019? and also a female entrepreneur at that. But can you just tell about the environment for startups? You know, how you find it? Is it easier to access capital than it used to be? More accepting? You should get a little bit into that. That'd be wonderful.
Our project was born on the right time because now in Russia, it's a lot of support from their Skolkovo and also from the different kind of the institutes who suppose even the grant support for the development, for the strong development designs and smart solutions. So, and also we have a lot of venture capital groups and private capitals with the venture capital to support such kind of projects. Because before, I suppose that it wasn't possible to develop such project like we do, like separately from the university lab. Before it was possible to do only in the university lab, like the university projects, and it means that it never is going to be a product. It never is going to be the commercializing project or so on. That's why we had a lot of technologies before that never was set it up like the real products, and the world never will see them and never will use them. But now it's the different situation. So we have really great support from Skolkovo, that's true. And we use a lot of services from them. So it's also as the IP service that provide us the ability to get the patent, the patents, to apply for to issue the patents, and also to move this patent to the national phases to different countries. So it's possible to work not only for Russian market, to present our products not only in Russian markets. And also we have this strong support from their Skolkovo from the GR point of view, because it's very such a smart and social project like we develop. So the exoskeleton for rehabilitation, it's more for their, it's very important from the government point of view. It's not so easy to, it's not so open market, because their people should not buy the exoskeletons for themselves by their money, because it's very expensive product. So it must be provided by the government, it must be covered by reimbursement programs, and it must be set it up on the hospitals and provide like the service, like the rehabilitation service for the people. That's why we need the government support, and Skolkovo helps us a lot. So if there is no Skolkovo, so we are like the small startup, is not able to knock to their functionaries' doors, you understand me? So, and the same situation I see in South Korea, where we have the daughter company. So the government from the South Korean government, they helps a lot for our company. So we have there the manufacturing, and we have there the R&D center also, and they support us with the grants for the development of new products. That's the Asian market is very interested in. And also we see the same situation in the Luxembourg, where we have the European company for development, the European market. And now we even have the company in US, in Denver. Okay. So we are going to, now we started the pre-marketing US market. So, and we collaborate with the Craig Hospital and with different other hospitals. Because people need the technology all over the world, and ExoAtlet with the other competitors try to make a new trend in rehabilitation, because the exoskeleton, they provide the ability to walk on the normal surfaces. It means that it's the most natural way to recover the function, the walking function.
Yeah, so, go into a little more about that, if you will, because your core top focus is rehabilitation medicine, whether talking about strokes or injuries, things of this nature. I mean, and we're going to after the show, we'll link to your website and other things that you're associated with and other projects, news articles, and so forth. Can you just briefly walk through the basics of the technology and how, ultimately how you see, somebody, as you mentioned, the sort of getting access to it, once the reimbursement is there and so forth, and how the whole process works from, God forbid I was in an accident and then I require an exoskeleton. What's the process look like? And then, where does it take me as a rehabilitating patient today?
We are dreaming about to recover the own function of the person.
Mm-hmm.
So his own working function. We are not dreaming about to make a keyboard of the person.
Right.
So, but for example, the Japanese guys, they look to the more to keyboards than for rehabilitation. So there are different kind points of view.
Sure.
So, but we work on methods that combines the classical medicine and the exoskeleton, like their strong improvements, like the booster to improve the own function of the person. So that's why we combine the myostimulation, for example, the stimulation of muscles, right in that phases when they must work. So when the person is walking, right on that time when the muscle must work, we stimulate it. And also we work with their spinal cord stimulation. So it's the combination of the methods. And for sure, the cutting edge is their brain-computer interface. Because a lot of scientists, they're interested in this kind of combination, and it's the great field of research, how we can get their biological feedback from their brain using the brain-computer interface, the exoskeleton, and for example, the mirror and the feeling, the back feeling from the walking and so on. So there are many kind of the new technologies that we have to research their effectiveness. Right. Because the rehabilitation, it's from the economical point of view, must be very accurate designed, not to spend much more money that it's needed for the normal person, for the patient, because it's a lot of people need the rehabilitation. It's more than 3% of the population of every country. So that's why, and the government doesn't want to spend so much money for rehabilitation as to support these disabled guys, because everyone wants to get their effectiveness model, the effective model, how to spend no more and no less money to give the best results. So that is the new, that's the economical point that everyone wants to reach. And also the cost of the equipment must be lower. And their number of their physical trainers who support this rehabilitation process must be very, so it's no more than one person, for example. And of course, their sensors and their maintenance of all these solutions and devices should be very connected to all our other expenses. Because in other case, we developed the great technology, but it's never or no ever will be using in a normal life in hospitals and so on. And for sure, now the rehabilitation is the long-term project. So it means that the person started in a hospital, but it must be continued at home, because there is no idea to the patient lives in hospital for years. So he has to stay at home, he has to continue his normal life and so on. So in this case, we have to provide some solutions for home using. It's not like their solution that he has to forget about the wheelchair. No, it's some kind of the rehabilitation equipment to use it. Maybe they're supervising of the doctor, so maybe using the telemedicine or some different solutions to be sure that he continues his rehabilitation process. And when he will when he goes back to the hospital, so he gets some more strong support. I mean, maybe mind stimulation or spinal cord stimulation or something very important for him to boost and then to continue again at home. So this is the most effective economical model that we see, and we developed it. Because of course, for sure, there will be some connectors that can connect there. The hole, for example, in the spinal cord that, for example, the patient has, or some Maya connectors, or some new technologies that will provide the help to the nervous system. But now, as we don't have it, we have to get some kind of methods for getting much more better for to improve their working functions every day. So because we see that patients get so they get improvement in their mood because they want to live, they want to become better and better. They get families, they even get children. So it's so great that we see this result. So they want to continue their maybe studying or to get the new job, and a lot of things. So it's from the social point of view, these are patients, they are not patients, they're normal people, but with some disabilities.
Right, and I think that's an extremely important point. I mean, you're mentioning, quality of life. At the end of the day, that's what you're giving, and that's the core component. And yeah, if you can think of not just sort of the physical aspect, but the the psychological component of being, in a state of rehabilitation and the depression and everything that would come with it, you're affecting much more than just the biomechanics. I mean, you're really, I see how this trickles down to so many aspects of the patient and their experience, and I think that's great. You've spoken a lot about some of the more futuristic components that you envision down the line in terms of brain-computer interfaces and things of this nature. I was thinking, slightly in sort of the shorter term perspective. You and I have both at times been involved with the Human Enhancement Council with WEF, which is also the Longevity Council now. I was thinking more sort of the things less impactful than spinal cord injury, things like this. But I think about sort of all of the, just here in the U.S. alone, but all of the elderly with hip replacement or a knee replacement, or some of not as serious as a spinal cord injury or traumatic injury, but whereby they all have trouble moving around. Do you see opportunities in the short term or sort of the medium term for assistance in some of these cases where you might not have the full exoskeleton, but other types, maybe a lighter device that for less severe cases where you have these extremely large populations of elderly people that need a boost in some way or an augmentation? What's your vision about sort of that space?
The Asian market is very interested in such kind of solutions, as for example, the US market, I suppose, because to support their elderly people, it means that we can continue their normal life for maybe decades. Now, it's not like a rehabilitation device, it's more like the gadgets.
Right.
And of course, we have to find a solution to make it not so expensive to use for normal walking in parks or along their, to walk to their shops or even to reach their working office. So to reach the office for the elderly people. So we are looking to these fields, and we think that it's they're like a spin-off for such kind of smart and very complicated solutions like the exoskeleton for rehabilitation. And of course, a lot of people who use it like it will be so this so are normal. Like for example, now a lot of Asian people wear the mask to keep themselves from the pollution. So it will be the same. A lot of people will walk along the aisles, along the streets with this kind of devices. And of course, it's not only for the elderly people, but also for workers in the industry. So we have to protect them because a lot of workers, they have to carry the heavy things, pick up from the floor and put to different kind of surfaces. And this kind of radiculopathy, it's the problem that they get when they carry heavy things.
Sure.
It's not for the real robots, but it's for such kind of devices like their variable exoskeletons. It can be not the fully skeleton, but it can be the parts of the skeleton and some such kind of assistive device that's not so heavy and not so expensive, and the owner of the factory can provide it to the worker without any hesitation that he can break it down or something like that. So it's important.
Oh yeah.
Because, as we know, not every company is ready to provide for the workers some expensive attributes.
Right.
Equipment. Yeah.
I know that story very well.
But it protects their back, and it means that in the future they could work maybe longer and they can win more money. The world will be much more happy.
Yeah, and I definitely, as I said, here in the U.S., I mean, the whole area of occupational safety and health and workers, compensation problems that come from injuries, I definitely see the amazing possibilities, and not just in the U.S., but just industrial sites all over the world, how this technology could ultimately be applicable. So
Right.
I find that fascinating as well. I mean, it's amazing things that you're involved in. Typically during this show, we sort of transition at the end from sort of the science and technology and the business into a little more science fiction question. But I would like to propose it to you just to get your feedback. I would like to ask you, if you had the opportunity, Ekaterina Bereziy, to travel anywhere in time and meet somebody that you wanted to talk to. It could be a business leader, a politician, a religious figure, whomever. Who might that be? And if you had the opportunity, what would you want to talk to that person about? You can take your time to think that one through if you want. You can go anywhere you want, any time period, any location. Who would you have liked to meet and talk to?
I think that it's for sure the person from the scientific field. So it can be, for example, Marie Curie. So she was one of their, I don't know, it's exactly chemical or physical, but I suppose that it's the physical scientist. So she, as you know, she developed their gamma rays and the radiation and so on. So I am wondering, so how she how she jumped over a lot of obstacles that she met during her researches, because she didn't know anything about the radiation, and from the theoretical point of view, they didn't know anything about this field, so they get a lot of experimental results, and they had to explain them. And as usual, when you try to explain the things that you can see by your eyes, very obvious, it's a lot of arguments from the scientific fields and the scientific colleagues who tells you that it doesn't work. So it's a coincidence or something like that. So one of the most important questions, how she jumped over this obstacle of the audience opinion, because we have completely the same. We see that we can recover the walking function of the patients, but the medical society tells us that it's impossible, completely impossible. But we have cases, we see these guys who can walk right now by themselves, but we can't explain it. And from their scientific point of view, it means that it's not their science, it's not obvious, it's not proved, it must not be like this. It means that it's not necessary to develop it because it's not proved. So the question put to her is how she explained it to the society and the scientific guys. And where did she get the internal, I don't know how to say, feeling to jump over this?
It's wonderful. That's a very elegant answer. And I joke when I hear that same story over and over about, if everyone listened to people that said that things are not possible, we would have nothing. So, no, that's I completely, and especially in an area that you're involved in, where we know so little about neuroplasticity and the central nervous system, and if you make things work, they're working for a reason, and we should, yes, we should follow these things and not throw them away. And it's completely agree with you. Ekaterina, I really appreciate so much coming on the show today and everything you're doing. As I said, we will be linking to your site and other resources associated with you and the company. But for everybody, we've been talking today to Ekaterina Bereziy, founder and chief executive officer of ExoAtlet, at the epicenter of human exoskeleton work for rehabilitation, and really fascinating things that she's doing. And everyone should check out the website and really keep an eye on what started as a Russian story, but has expanded to Asia and the United States and Europe, and is really a wonderful example of science and entrepreneurship coming together in one unified package. And it's just a lovely story, and I'm going to keep following you, and the ideas that you bring are so important to the 2019 world and beyond. So thank you once again so much for coming on today and sharing your knowledge with us.